Hey, I'm here.
Okay, good.
Hey, how's it going?
Hey, David. So everybody, welcome to our meeting for Enterprise Network Security and Automation on June 2nd for our second meeting of the summer. Real quickly, I want to throw some things out there to you. First off, inside of our class, I did drop in for NetLabs. One of the things you will see is that NetLabs has a document that has been updated for NetLabs only. So one of your classmates wanted the documents in Word, so I converted all the PDFs to Word and have placed them inside of the class. So if you go under modules, there's now a lab documents in Word format. I will be doing this for the other two classes also, so that if you use NetLabs, you'll have the Word documents already converted. You could always have taken the PDFs and opened them up in Word and had them, but I just went ahead and dropped them in here for you. And you'll notice there's not a great deal of NetLabs labs in this class, so just be aware of that. In fact, I think this is probably the least I've seen in any CCNA course in a very, very long time. The other thing I've started doing is if you'll scroll on down where I've got your uploads for assignments, I have completed lectures now for modules 1 through 4. And so when you click on Module 1, it goes through the single area Ospf concepts, and then I've got the link for Module 2. I'm sending these in emails, but I'm also dumping them into the class, so the lectures will be here. You also could obviously subscribe to my YouTube channel and get information when I post about it. But the first 4 chapters I've got lectures on. Feel free to use these in your classes. They're on. I've got them on YouTube. There's no, I mean, they're not. Hey. You'll see when you watch the lectures, I tell you up front, I do it just like I would in the classroom. They're not going to be perfect. You're going to hear ums and ahs. You're going to hear me stutter. You may hear the phone ring. You may hear, I'm going to move this camera over here so I'm not looking at there. There we go. You may hear the phone ring. You may hear somebody walk in my office. But I go with what I call good enough videos. None of us are perfect in the classroom, so I don't try to be perfect in my videos, but I do have lectures for those first 4 modules, and I hope if I can keep my pace going, I'm hoping to do 2 per day for the next couple of days. I am taking next Monday and Tuesday off. I have 39 hours of personal leave that I need to use or I'm going to lose by the end of June. And, you know, I like my job, but I'm not going to give them 39 hours. Be aware that I am going to hold our class meeting next Tuesday. I'm going to do that even though I'm technically off, but I'm not going to be in the office those 2 days. So you may not see any videos on Monday and Tuesday from me. You'll see them Wednesday and Thursday. In fact, I'm going to take the next Monday off for the next couple weeks just to knock out those days. Last year, I think I gave back 30-something hours because typically in June, I'm in. This week, I would have been at Cisco Live. And then in 2 weeks, I would have been at Skills USA National Conference in Louisville. And so, you know, none of that's going on. So, hey, I'm at home. So I won't have to give a bunch of time back this year. I do want to, before we continue on, ask, are there any questions? Do you have any issues that are going on with the class? Any problems that you've seen so far?
I'll have some questions when I go to get on the NetLabs and do those labs virtually. I've never done that before. Because my other CCNA classes that I took, I was actually physically sitting in a lab. So I physically got up and did that stuff.
I think once you start using the NetLab system, in fact, I'll go ahead and start a reservation just so you can see that first. But typically when you go into NetLabs, you just log in with your username and password that I gave you. And I'll actually send out a video on how to do a reservation. But you can go in and you can just do schedule a lab for myself. In fact, looks like somebody in our class is doing a lab. And then go down to your class, which in this case is KFC. That's my initials, by the way. Kelly Franklin Cottle, but Kentucky Fried Chicken. KFC ENSA Sum 2020. You'll then see there's 2 different items here. One is just the MDP pod, multi-device pod, and one is the skills assessment. Don't use this until you actually start doing your hands-on exam at the last part of the class. So this is only for the hands-on final. These, when you click on the first one, you'll see a list of all the labs that are available. And then you just click a lab, and pick a pod. Now here's the important thing I want you to notice. It looks like there's only 4 pods here, but if you click this little arrow, there's actually a whole lot more pods out to the side here. So we've got 11 pods online right now. Pod 1's off because I'm having a switch issue in pod 1, but I'll get that fixed soon. So we have 11 pods online. You can pick a time. The red line is the current time. And if you know you've got time Thursday, the 4th at, 4 o'clock in the morning, you can go, whenever. So you can also go forward and schedule labs at any time. I always ask, if you do that, just make sure you're using the pod when you schedule it. This summer, it's not as bad. The fall is going to be a little rough because I'm going to be trying to share the system with so many people. But if I click right here on the red line, it then gives me 6/2/2023 and I'm just going to just throw it out here to like 2 hours and 40 minutes. The maximum is 4 hours, and the lab will also end 10 minutes before your actual end time. So if you got 2 hours and 40 minutes scheduled, you really only have 2 hours and 30 minutes to work. Most of the labs you could get done in 2 hours. I would just schedule 3, and then when you get done, just end the reservation. So it's not all that hard to do there. So now once you schedule a reservation, you will see that now I have a reservation for myself and I have an inner lab tab. If I click here, you'll see the labs initializing. At this point in our net labs down the hall here, 2 Cisco routers and 2 Cisco switches are in the process of actually booting. So this is real gear. And if I leave it here long enough, you'll actually see it get turned on. Right now it's turned off. You'll get to see it turned on. So it just got turned on, and you'll see it start the boot process. So it takes usually about 5 to 8 minutes, could be up to 10 minutes to boot. Doesn't typically take much more than that. And so I'll come back in a few minutes. But one of the big things here, when you look at the content, you'll notice this has been modified for use on NetLab. So don't use the documents from inside of our class. Use the documents I've posted in the modules under our course. Like I said, you'll see it's just a regular Cisco 40. These are 4321s in pod 12. You see the switch is booting too, and this other router is booting. So, and this particular one does not have any PCs on it, so there's no PCs booting. And like I said, real gear, so it is booting up. And I'll come back to it in a minute and show it to you.
And those are just pretty much similar to the packet tracers. If it follows suit with the previous courses, like normally you would have hands-on labs and you'd have a packet tracer, and they're pretty much identical other than IP addresses and et cetera, et cetera.
Very similar. The only difference is the packet tracer typically gives you it hand holds you. And so it, hands hold you. And then the, now what they've done with the content here is they're actually just saying, okay, do this, do this, do this. So they're saying configure the interfaces as shown, enter Ospf using process ID 56, do your static router ID, network statements. So they don't give you the commands in the labs now. So really, and this, they've switched this multiple times in the curriculum, by the way. This is how it used to be 2 versions ago. The packet tracers would give you all the commands, and then the hands-on labs are for you to take those commands you learned and put them into the hands-on labs. I like both. I think in some ways, I call the packet tracer monkey see, monkey do, because they just say do this, do this, do this, this. And then the hands-on lab takes the concepts that are all inside of these packet tracers here and applies them to real gear. So I would suggest do your packet tracers first so you know the commands, then do the actual hands-on lab. So, because you'll see here when it looks at propagating default route and all these things, if we go into NetLabs, you'll see in here as you get toward the bottom, change the reference bandwidths, doing the ping to loopback interface, default route. There's even here, it tells you to create the default route. Where's it at up here? I don't know exactly where it's at, but in here it tells you to create the default route and then redistribute it into Ospf using the default information originate command. So pretty much all the things that are in the packet tracers are in one single lab in the curriculum. But again, you've got, this is a real router booting real iOS, so it doesn't take, it's not something that's super fast. But the good news is it's real gear. I mean, like I said, it's not, you've got the quirkiness of real gear, and it works like real gear, which is something I really like versus the packet tracer. Packet tracer is great, but it's just not the be all end all. I will tell you folks, one of the things I've been working a little bit on is, or playing with is CML Personal. I don't think this is a good thing for CCNA right now. It may be something to look at for your CCNP classes down the road, but it's got virtual iOSs in it. And this is, actually I've got it at home. So next week when I have my class from at home, I'll pull up CML and show it to you. But it basically runs inside of VMware Workstation. And it allows you to do some things in a simulated, and really this is not even simulated, this is a virtualized environment for the iOS. This is the legal way to do GNS3. You know, GNS3 is not legal unless you legally own the iOS images. And there's a lot of schools using it, and they use it for their classes. And if you don't own that iOS image, you are illegal. I mean, you could be slammed for that. But I'll show you more of this next week. We'll play with it, and it's not exact because this iOS VL2, the virtual layer 2, is an older version of the iOS that requires some differences. Like for instance, on the trunks on a switch, you had to do switchboard trunk encapsulation .1Q because it supports both .1Q and ISL. Well, our current, these S1, S2, they don't support anything but .1Qs because they're 2960s. But we'll talk a little bit about CML next week. If you get a chance, take a look at it. I would not say buy it right now. I would say watch some videos on it. I think one of you said David Bomble is a YouTube channel. I don't remember which one of you mentioned that, but one of you did mention it to me. And so he has a YouTube channel that he goes through a lot on the CML stuff, how to set it up, what it is. And by the way, y'all are over here. That's why I keep looking over there. I've got your pictures over here on the side on my other screen. So that's why I keep looking over there. So that's something we'll look at. It's pretty good. Like I said, it takes a lot of resources. It takes 8 gigs of RAM and pretty beefy processor to run it, but I think it's got some potential. Definitely has potential, I think, and I got to find the legality on whether or not I can take this and put it into NetLabs pods. In other words, for every pod, buy a single copy of CML Personal and put it in each pod, and then use that for CCNP, which would save me some money because $199 is a whole lot cheaper than a $3,500 pod, or a little bit more. But like I said, here we go. We got routers. There it is. So we got a real router. These are 4321s. So 4321s, show platform. And they're running 16.7 3R firmware version. Okay. So that is in here. We've got our lectures. I've got the documents now. All right. Any other questions about NetLabs?
I will mention on the Lab 3, the NP cap needed to be loaded manually on the pods that I used. I tried on several, and it looked like it needed to be loaded manually. So
say that again, Stephen. What on Lab 3? On
Lab 3, the Wireshark lab, it
okay.
looked like the NP cap needed to be loaded manually. But I only tried it on a few of the pods.
Okay, so you weren't able to get the capture to work?
No, I got it to work. I just had to load NP cap manually. So
okay.
I went into PowerShell,
gotcha.
and then loaded it.
All right. I'll test that. It may be that we can do. It may be. I've had some issues with those. Maybe I can do. By the way, if you ever need to end a reservation, just go to reservation, end reservation now. But I'll try that lab and see if, in a little bit, see if I can't figure out what's going on there. Maybe if we run it as admin when we run Wireshark, that would do it. But if not, we can. If you don't mind sending me what you use there, Stephen, I'd appreciate that, and I'll send it out to the classmates or post it in the discussion forum.
Okay, no problem.
just to see what we got. So hold on, I'm gonna mute you for a second because my coworker's coming down the hall.
About same time in the morning?
Yeah, he's been working in the data center all day, so. Okay, so one thing I want to do, folks, is just, if you haven't looked at module 1, I do want to kind of go over these concepts with you, just to ask you if you have any questions about them, because the concept of an autonomous system is not really discussed in the curriculum per se, not in the section on OSPF anyway. And an autonomous system is a group of routers under the control of a single administration running the same IGP, so the same interior gateway protocol. Inside of that, now we talked about distance vector versus link state before. Are there questions about really the differences between these two? And I know a lot of you, like me, were probably taught that EIGRP is a hybrid protocol, but it is not. It is truly a distance vector routing protocol. Now it borrows some link state concepts like triggered updates, adjacency table, topology table, but EIGRP is still a distance vector routing protocol. We don't even go over EIGRP anymore really in depth at all in CCNA. OSPF is the protocol of choice. We do not go over BGP, which is our only exterior gateway protocol. And I cannot say enough good things about these videos by learnnsrc.org. In fact, you can see that I've got them up. I've been watching them today myself. It basically goes through what is routing. Talks about, I mean, by the way, if you want to learn about, it's not just BGP, I have an entire section on introduction to OSPF. So here's an entire video on OSPF. And I like this. They've got these little exercises. OSPF is a link state protocol like ISIS. And you go next, and it basically has little exercises that gives you the ability to do that. So you've got ISIS, OSPF, these are all interior gateway protocols. But you can see there's a good four videos here on OSPF. And that is learn.nsrc.org. But I will tell you even better than that, with BGP, man, they got all kind of BGP stuff. You can look at 109 different videos on BGP, what it is, how it works, how to set up interior BGP versus exterior BGP, and external, internal, not interior, external, but internal, external BGP, how to set up iBGP peers, all kinds of cool stuff. So if you want to learn BGP, you got a good resource right here. Questions about the differences between those types of protocols. How many of you are familiar with, that's my access list video I just did. How many of you are familiar with these concepts, or do you have any questions about these concepts? One thing I didn't mention in the lecture that I do want to talk just a bit about is the difference between administrative distance, which is covered earlier in the curriculum, and versus metric, okay? Now, so AD is the desirability of a route between routing sources, okay? So for instance, if I had the network 192.168.12.0/24, and I had a route to that network from both RIP, and I had one from OSPF, and I had one from EIGRP. In other words, I'm running for some crazy reason, all right? It's insane to do this, but this is a lab environment. I'm running RIP, OSPF, and EIGRP on the same router. And that router has learned from all three of these sources a route to the 192.168.12.0 network. Administrative distance is used to determine that, okay, RIP has an AD in the Cisco IOS, by the way, of 120. OSPF has an AD of 110. And EIGRP has an AD of 90. Cisco proprietary protocol in the past. And so what happens is the route with the lowest administrative distance would go into the routing information base, into the RIB. So first off, and this is where metric and AD differ. The metric is used to find the best path within a routing protocol. Okay, so RIP has a metric, and RIP's metric is what? Does anybody know?
Hop count.
It's hop count. Okay, so not hope, but hop count. So basically, the shortest number of hops, shortest number of routers you go through, that's going to be the best path, even if there's a one hop more that goes through two different, 100 megabit links or gigabit links, and the other one is 56K link. Doesn't matter. Shortest number of hops. OSPF, as we've learned in our curriculum, goes off cost as its metric, and cost is a figure based on speed of the link. Speed of the links. And we talk about the auto reference, bandwidth, cost, and those types of things. And then EIGRP has a metric that is actually bandwidth plus the sum of the delays. And there's actually an entire set of, there's multiple different things in EIGRP, but what it ends up being is it's the bandwidth plus the sum of the delays in a link. And so the one with the lowest metric wins. So the first thing a router would do if it had all three of these routing sources is it would take the metric and find out which one of these inside of that protocol, what's the best route. So it'd find, using the metric of RIP, find the best RIP route, find the best OSPF route, and then find the best EIGRP route. Then, once that has been determined, a decision has to be made about which of those best routes from those routing protocols will be placed into the actual routing table. That's where administrative distance comes into play. The routing source is looked at, and then based upon, and quite honestly, in somewhat an arbitrary manner, other than the fact that, does anybody know what the static? Well, first off, what is connected? What is the idea of a connected link?
Zero.
It's zero, which that makes complete sense because you can't get any better than being connected to a network. And then static, depending on how it's been configured, is either a 0 or a 1. Okay, if it's an outgoing interface, it's 0. If it's a next hop, it's a 1. But by using these ADs, you determine between routing sources which one goes in the routing table. Does that make sense?
Yes.
Okay. Now, distance vector routing protocols, for the most part, historically have used simpler metrics. Another way I always use an example for metrics is the metric is how we're going to determine where we're going to go eat. Okay, well, first off, we decide we want to eat Mexican food. Then we take our metrics and we say, okay, what's the metric for the Mexican restaurant we're going to? Which one's closest to the school? Which one has the best salsa? Which one has beer on sale? Which one has salsa on sale? We have metrics within inside of our Mexican restaurants. We decided we're going to eat Mexican. Okay, so we're in RIP. Now we take the metric and figure out which one of the Mexican restaurants we're going to eat at. So we're going to find the best one. By the way, it's been a long time since I've been to a Mexican restaurant since the COVID-19 thing. So it might.
No, that's not fair. Now I'm wanting chips and salsa.
I know. I'm like, man, I need some salsa. I'm thinking I need to go.
I think I'm going to go to the fridge and break out a beer real quick.
So we use that metric to determine the best restaurant. Well, inside of a routing protocol, use the metric to find the best route. Then use administrative distance to place the best route, quote, best routing source into the routing table. And that's really not discussed a great deal in this. It's discussed back in chapter, I think it's in semester 2, chapter 3 or 4. Can't remember. I hadn't learned this new curriculum as well as I knew the old curriculum, but it's in that same area as discussing static routes. They go over the difference between AD and metrics. All right. So OSPF is what we call a link state routing protocol, which means it has a full understanding of the network. It has a fairly complex metric. I don't think it's all that complex though, because it's just the cost of the links. It is harder to configure and not any harder really in the IGRP, but a little bit harder. And it uses what we call triggered updates, so it doesn't wait for an update, for something to change in order to actually perform an update. So I was going to jump over here for a second into our concepts and see if I can't show you. So when we look at this, basically the routers do not perform what is known as routing by rumor. That is a distance vector characteristic. In link state, we flood out all of our link state information to all other routers in the entire network. So everybody has a full view of the topology of the network. That's important because it makes it quicker to converge. We also have, with the understanding of that nature, we're able to execute the SPF algorithm better because we understand the entire topology and the cost, and we can figure the best path based upon that cost. One thing that does get people in trouble sometimes is when you're looking at costs on a link, it does include the cost of the destination network. So it's not just the traversal link. So in this case, if I'm going over to 10.11.00/16, the cost to get there via this path is 32. All right. And then up here, it's also 32. Now that means it's equal cost. By default, OSPF, trying to remember, does not.
Isn't it the MAC address or something that it uses? Whichever one has a lower MAC address, if there's a tie.
If it's the same, yes. And then it's based upon, you can't actually do equal cost load balancing. In fact, I think OSPF will equal cost load balance up to, is it 4? I think it's up to 4. I think we'll equal cost load balance up to 4 different networks. Now, what you're talking about, David, is how is it going to send the first packet as it load balances across those 2 links? And so you're right. It uses the MAC address of, if there is a MAC address, it uses the MAC address, lowest MAC address, to use that as the first of the 2 load balancing links.
Okay, all right.
Yeah, you're right. That's pulling a good one there, because that's way back from the old curriculum. Yeah, let me check this. I'm gonna look this up just to make sure. 4. Yep, I was right. Golly, you can pull stuff out of. Pull it out the back. It is 4 equal cost paths by default. OSPF will load balance across. OSPF will not by default, and doesn't have the ability to actually load balance across unequal cost paths. EIGRP does with a command called variance. So, by the way, my Google foo is strong. Sometimes I always tell people you can't know everything in networking, and sometimes I forget stuff, but it will load balance across automatically 4 equal cost paths, which is kind of cool as a protocol. And then choose the best route, and that's what it tries to do. Unless I did some figuring here, 11, R1, R3, R4. Yep, that's 5, 10. Actually, that's the best pass here. It says 5, 15, 20, 22. So it is, or 27. I got something wrong here. 5. Yeah, forgot the 2 here. So 2, 5, and it gives you 27. So by knowing the entire topology of the network, the routers can make better routing decisions. And that's the key for a link state routing protocol. We don't do a whole lot with multi-area OSPF in this class at all. That's an enterprise core concept. But the big thing here is that by using multiple areas, you can bound the area within which links going down or flapping or even updates being sent out. You can completely bind them inside of an area and then do summaries outside of the areas. I will tell you, when they get into this entire section here on the different packets and get pretty detailed into all of these, I don't think for the CCNA you need to know more than these type 1s through 5 in terms of what these are. You really don't need to, or don't have to, drill down into the different types of link state updates. So there's type 3s or type 4s are link state updates, and then inside of type 4s there are subsection types of link state updates. And so these are the LSA types, the actual link state advertisement types that are under the LSUs, and that's why they're kind of breaking down in here. So you've got your link state updates, and then there's a LSU types that come in here. Some of these are up to 11, but some of these only, well, most of them only apply inside of a multi-area network. And we don't go over the great deal of them for what we're doing inside of CCNA. One of the big things I will tell you is make sure your OSPF neighbors all have the same hello and dead interval, which gives you your wait interval too. If they do not, they will not form an adjacency, unlike EIGRP. EIGRP will actually negotiate hello timers, but OSPF will not. It just won't form an adjacency, which I think is a very important thing to know. You also notice, I mean, if you look at this, I mean, knowing what you know about networks and looking at this hello packet content, that's a pretty complicated header. I mean, look at all the stuff in that header that's going on there. You know, the very least we talk about the difference between the amount of memory and the amount of processing it takes to handle OSPF versus distance vector routing protocols. Think about it, every time one of these comes in, it has to be taken completely apart and looked at and then passed up to OSPF process. And then, you know, then we do, so a header with this much information in it, obviously it's going to put more strain on a router than the simpler header found in RIP v1 and even RIP v2. Although RIP v2's got a decent sized header on it, to be quite honest, when you start looking at what's inside of it. But you'll see inside of these hello packets are held authentication. There is the ability to do authentication inside of OSPF. So that is hid inside of these headers if it's required. The dead interval, the hello interval, the priority, which remember the priority is 1 unless it's changed. And then you've got designated router, backup designated router, and the list of neighbors. So any questions on the OSPF header?
No.
One quick thing to remember is this: OSPF version 2 is for IPv4. OSPF version 3 is for IPv6. That's, for the most part though, that's the big difference between them. One is set up to handle and carry IPv6 routes. The other is set up to handle and carry IPv4 routes. I'm not going to go through a great deal of these. I do in my video talk about stuck in a NIT, which is typically when you have only one-way communication across a link. In other words, one side is receiving a hello packet, but it doesn't have its router ID in it. And so it's sitting there trying to initialize, but it's never seen its own IP address and a hello packet, and it can't go into the two-way state. The two-way state is when the two routers have exchanged hellos and they see one another's IP address inside the hello packet. Then they're able to send a two-way, and then it goes xstart exchange, where it starts sending the database description packets. And then once it goes through that, we'll get the loading state, and that's where you start saying, hey, I need a little more information about this network. And then we'll get a link state request, and then we'll get a link state update that says, oh, okay, well, here, this network, this is what I know about this network. And then finally, when it's in a full state, the databases are synchronized, and everyone should agree upon the topology of the network at least. So again, a difference between this and RIP is we have a neighbor adjacency table. So we have a neighbor table, show IP OSPF neighbor. So that requires memory. That requires processing power to build and maintain. We're going to have a topology table. So once we actually get through these three states here down to a NIT, we do our NIT state, we get to the two-way. If we're on a multi-access, we will elect a DR and BDR. All right. And then after that, we'll start sending out our database description packets, beside the first router, which is typically the highest router ID. Again, how do we get router ID? What were the three possible ways to get your router ID in OSPF? Anybody want to take a swing? Stanley, give me one of them.
You can assign it, the router ID, like they had us assign like 1.1.1.1.
Yep, and that's probably the preferred method. You can assign it as the router ID. What's another way, David?
I don't remember. I haven't read it yet.
Okay. Well, Steven, you got another way?
Address.
It can be the highest IP address on any loopback. or the highest IP address on any physical interface. So it's one of those three. It's either going to be the router ID that's been assigned under router OSPF, or the highest loopback, which takes precedence over the highest physical interface, highest IP address on physical interface. And that's literally just the highest. So if it's 205.10.10.10 versus 203.10.10.10, 205 wins. That's the one that's going to have the highest router ID.
What about the highest router priority?
The router priority is used for the DR/BDR election if it's set to anything different than the default. The problem is, by default, when we look right here at this DR/BDR or a DR, by default, the router priority on all interfaces is 1, which means the highest router ID will become your DR.
Right.
So router the priority doesn't have anything really to do with the router ID.
Well, on one of the test questions on modules 1 and 2, one of the routers had a priority of 255.
Okay.
And so it was going to be the DR.
Correct, but that had no effect on its actual router ID.
Oh, okay. Yeah, I was talking about the D. Okay, and I see what you're asking.
Yeah, that's what I'm saying. I agree. When we get down here talking about DRs, I agree with you completely. When we look at a DR versus BDR, and the whole reason we need DRs, and I want to jump over here real quick before we go any further. This is single area OSPF. I want to show you this because I showed you that I do this in the lecture, but I want to show it to you anyway. Config T. Do show IP in brief. You'll notice there's no IP addresses set on this router at all. So now if I go in here and I'm gonna give it a host name just because that irks me. If I do router, I cannot type OSPF1. Watch what happens. I'm gonna get an error message. Because remember, you either set the router ID with the router ID command, or it's going to take the highest address on a loopback. Well, there are no loopbacks configured. All right, so it can't pull from the highest loopback, or it's going to pull the highest physical IP address or highest IP address on the physical interface. No IP addresses are set on a physical interface. So I cannot start OSPF because there's no router ID. Now, a couple ways. That's why I could set the router ID, router-ID, and I could do 1.1.1.1. And now, if I do a show, do show IP quote. Okay, actually I got to do show IP OSPF. You'll see that on the process ID 1, my ID is 1.1.1.1. So I physically set the router ID. And that's the best way to do it, because imagine this. Let me go back in here and let me do a Control C and do no. Well, let me do the up arrow twice. And hopefully Control A, no router ID. All right, so we just took it off. And so now I'm gonna go do int GI000. Let me do a do show IP OSPF right now. Let me do it. Let me clear the OSPF process. Do clear IP OSPF process. Yes. Okay. Then do a, oops, went too far. Nope, still hanging on to it for some reason. Let me do a Control Z here and drop out to a clear IP OSPF process. Now that should have cleared out the OSPF. Golly, I cannot type. It's hanging, it's keeping it there since it was already inside of there, even though if I do a show run, it's interesting that it did not, even though I cleared it out, it didn't remove it. Very interesting. I bet if I know if I reloaded it would go away. But anyway, let's do this. Config T. Int GI000. I sure wish I could type like I used to. 192.168.12.1 255. A no shut. Very important. Oops, no shut. I think it was already up, but do clear IP OSPF process. Yes. Now do show IP OSPF. You'll see now, because I put the only thing up with an IP address on it is the physical interface, that became the router ID. If I go back in now under router OSPF1, and I do a router ID of 1.1.1.1, okay, do show IP OSPF. You'll see it's still set. Nope. All right, I'm confused now. We just learned something. Evidently, in this version of the iOS, when I changed it, it automatically makes up the router ID. What used to happen is you had to clear the IP OSPF process in order for it to take over. So in other words, you'll see I put a physical IP address on, cleared the IP OSPF process, it took over. I wish now I hadn't done. I wish I hadn't cleared it. Let's go over to R2. We'll try it over there and see what happens. So we've got this, which is what I put in, and then once I changed the router ID using the router ID command, it automatically updated it, even though I didn't clear the IP OSPF process. That's interesting. Let's try something. I'm gonna go over here. Sometimes we fly without nets, folks. But this is actually a very cool example. So let's do, again, do show IP int brief. And I'm going to show you that we've got nothing set. I'm going to do router OSPF 1, and I'm going to do router ID. So you get a failing, it fails there because there's no router ID. Do 1.1.1.1. Do show IP OSPF. And you'll see now we got a router ID of 1111, which I physically set it. That's what I should expect. Now I'm going to do the up arrow, Control A. Oops, I want Control A. I'm going to remove this from the configuration. Okay. I'm going to do clear. Actually, I'm not even going to clear it. I'm just going to do this now. So if I do a show IP OSPF, it's still holding 1.1.1.1. But now what I'm going to do is I'm going to go directly to the interface. Oops, I'm an idiot. Sorry, I was already in here. 0, 0. By the way, I'm in router 2, so I'm going to do IP add, and I'm just going to give it 131.107.0.1, 255.255.0, 0. Now, what should happen, I should have to clear the IP OSPF process in order for my router ID to change. But I'm guessing from the behavior I saw earlier that it's going to automatically change it. Nope, did not. I'm interested. That's very interesting. So we got it's up. Do show run. Make sure it's out of here. It is. Okay. And let's do a do show IP process again. All right, so now I'm tell you what I'm gonna do. Then I'm gonna clear it. Do clear IP OSPF process. Yes. And then now, poop. Same thing again. I cleared it twice. Just really clear it. And then now it did it. Now let's watch this. Router OSPF 1. Here's what I'm interested in now. Will the router ID? All right, I'm gonna prove to you. Do show IP OSPF. Okay, so my router ID is 131.107.0.1. Now I'm gonna set the router ID with the router ID command of 2.2.2.2. Not clearing the process. That's the exact opposite of what the curriculum tells you right there. When you read the curriculum is going to tell you that anytime you change the router ID, you would have to reset or clear the IP OSPF process. But evidently, in this version of the iOS, the router ID command will automatically apply it to the OSPF process.
So what version of the iOS have they written the curriculum to?
It's supposed to be this version. Supposed to be this one. Well, no, this is 15.5, so this is a little different version. Let me think of which router has the. Trying to think, but still, that should be should be the same. I mean, that's close enough. 15.5 versus 16.04 should be pretty much exactly the same. That's interesting, though. I have to do a little more research on that. It makes sense because if you're going to set it with the router ID command, you want that to be the router ID. But you would think that you would have to do the clear IP OSPF process. Learn something new every day, folks. I know in previous versions of the iOS, you did have to do the clear IP OSPF process for it to work. Let me see if I can find a.
Well, if that's the way the curriculum's written, maybe they're writing it to where get people in the habit of utilizing the older version instead of in the newer version of the software. It overwrites it.
That's true. That's true. I think the big thing there to remember is if you, well, and that you could think about the question someone brought up about the DR election. You know, your router ID is going to be what's used for your DR election if you don't change your priorities. And it's the highest router ID that will become the DR. And then the next highest will be the BDR. And so I guess if the router ID did not overwrite the interface as the router ID, you could get some very strange DR, BDR behavior. The other thing though is to think about when you set your router IDs, you don't want router 1 to just be 1.1.1.1 all the time, because again, if you don't change the priority, that one's probably not going to become your DR, even if that's your core router. And so if router 1's in your core and you want it to be the DR, you need to make sure its router ID is higher than any other router unless you're going to change the priority on the interfaces. So that's something to think about. That could be an issue. I had to play around a little bit more with the iOSs. I know there's a couple more. I'll play around with that and look and try to do you a little update next week on that. Questions about router ID and how to set it though, or where it comes from. Because it's pretty important. In fact, it's even used to determine who's the first router. So the highest router ID sends their database description packets first, and then the next highest will send the next over the link. So on multi-access networks, by the way, we will have what's called a DR or designated router. That is so that you don't have to form adjacencies between all routers. If you did form adjacency between all routers, it would quickly get out of hand. You would have a situation of, in even a network with just 20 routers, you have 190 adjacencies, which is crazy. So what we basically do is we create DRs and BDRs. I always go back to my domain controllers and backup domain controllers, primary domain controller and backup domain controller. I'm showing my age there. Talking about some age. Back in the old days, I worked on Novell stuff, by the way, so I know about some old stuff. I'm really glad I don't have to work on their junk anymore, unfortunately. I said it out loud, didn't I? But BDRs and DRs allow us to have a central point for LSAs. So they'll go there and then be sent out. And it's so that the routers only have to form an adjacency with the DR and the BDR instead of having to form adjacencies with all of them. And also so they don't have to send their LSAs to everybody. They don't flood them out to everybody. They actually just flood it up to 224.0.0.6, which is all DRs and BDRs. And then the DRs and BDRs, or the DR actually floods it out to 224.0.0.5, which is all OSPF routers. believe I got those multicast address correct. But to become a DR, your DR will be the highest router ID or the router on the multi-access link with the highest priority. And by default, all the links, and it is an interface configuration, all the interfaces are a priority of 1. And then again, if you don't want a router to ever become a DR or BDR, give it a priority of 0, and it won't ever become a DR or BDR. It won't participate in the election at all. One thing I do really, really like about the new curriculum is these check your understandings. I do think those are neat. I'm glad they've got those. I'm like the fact that you just read it and then here it is, and you're able to do that. And then you've even got, you know, a module quiz at the end that helps with getting the information kind of into your head. Okay, folks, are there any questions on single area Ospf concepts? None? Okay, well, I'm gonna stop the recording. We're at about an hour. Are there any